Hello there, Mr. Sutton here with the IM3 Honors 1-1 Extra Practice number 3 solutions on domain, range, and functions. For this problem, I want to know first off the domain of the function. So that's the x values going from left to right. On the far left, I have the x value -5, and then as I move to the right, there's no breaks until I get to this endpoint of +1, and it's a solid dot. So because of the open dot on the left, I'm going to have a parentheses -5, comma, and then I'll have a 1 with a bracket because of the solid dot there. Next, for the range, I'm talking about y values from lowest to highest. At the bottom, we have the y value -4. That's as low as we can go. As we move up, we can get up to +3, solid dot on that. And there's no breaks in between, so I can do bracket -4, comma, +3, bracket. Now, if you're wondering about this open dot here at 1, although there is an open dot there and the function doesn't exist at this particular spot, we do have a solid line over here covering that y value of 1, so we don't have to leave that out of our interval. Now, for whether this is a function or not, if I try to draw a vertical line that touches twice anywhere on this graph, I'm not going to be able to do it. Every vertical line touches just once. So that means that this is a function. Every input has just one output. For increasing intervals, I'm going up from -2 to +1 for the x values along this interval I'm increasing. So we'll do -2, comma 1 with parentheses. We always do parentheses for increasing, decreasing, constant. And now for the decreasing intervals, I'm decreasing from we're going down from -5 for the x value to -2. So that's -5, comma -2 for that one. For this problem, finding the domain first on this graph, we have x values going from left to right here. We can go as far left as -5 and as far right as -2, and there's no breaks in between, so this is all going to be one big interval. Now on the left, we've got an open dot, meaning I need a parentheses on -5. On the right, we have an open dot as well, so another parentheses, this one on -2. So then -5, comma -2, both with parentheses for the domain. For the range, we're just talking y values, and we're going from bottom to top here. So on the lower end, we've got -4 for the y value down here, and for the upper end, with no breaks in between, we have +4. Those are both open dots for the y values, so we're going to have parentheses from -4, comma, +4. Now for the function, whether this is a function or not that I'm looking at, if I draw vertical lines all across this function, all of those vertical lines will touch at most once. There's no touching twice for any vertical lines. So this is a function. And then for the increasing, decreasing constant, it's not increasing anywhere, it's not constant anywhere, it's going down for the entire length of the domain here. So from -5 to -2, that's going to be our decreasing interval. And that's it for this one. For this graph, to find the domain, I need the x values where this thing exists. So we're going from -5 over to -1 with no breaks in between or asymptotes or holes or anything. So then this is going to be, and because we've got solid dot here and a solid line here, we're going to have brackets, -5, comma, -1 for domain. For range, we're doing the same thing, but from bottom to top with y values. So we've got a solid line at the bottom of the shape here at 1, and a solid dot at the top here at 5. So we're going to do bracket 1, comma 5 bracket for the range. Now for whether or not this is a function, is it possible to draw a line that touches twice anywhere, a vertical line? And the answer is yes. For example, like right here, right? This is telling us that we have one x value that's giving us two y values back, which means that this is not a function. Since it's not a function, we're not going to worry about increasing, decreasing, or constant intervals. To find the domain on this graph, I'm looking at x values from left to right. Now on the far left, we have -3, that's as far back as we can go. And we can go on the far right here, this arrow is telling us we just keep going up and right forever. So we can go to +infinity for the x values moving to the right. Since I don't equal anything, I have no function value at exactly -3, and we have infinity on the right, we're going to use parentheses for both those. So I'll write -3 comma infinity for the domain. And now for the y values, the range, I'm going from a low value of -4 down here, which the graph does actually equal at some point for that y value, up to, well, this arrow is telling us we're going up forever. So that's going to be positive infinity for the range. So bracket -4 comma positive infinity. And this open dot right here doesn't really affect anything because there's also a solid line over here for the graph taking up that spot. So we don't have any breaks in coverage for our range. Now for whether or not this is a function, as I think about drawing vertical lines all across this graph from left to right, all of those vertical lines are going to touch at most once. I can't touch twice anywhere. So this is a function, which means we can talk about increasing, decreasing, and constant intervals. For the increasing interval, our function is turning around right here at x equals 0. So from 0 until positive infinity, our function is going up. So we can say 0 to infinity, parentheses, is our increasing interval. And then from -3, where we have this endpoint here, down to 0, we're decreasing. So -3 comma 0 is our decreasing interval of x values. For this one, to find the domain, we're talking x values from left to right. So I'm going left forever and right forever with no breaks in between. So therefore, we're going to use -infinity comma infinity for domain, and we're going to have to use parentheses because we're talking about infinities. Now for the range, it looks like it's a very less steep slant going this way and also to the right, but we are going down forever and up forever. There's not actually any asymptotes going on here. So since we're going down forever, we have -infinity, comma up forever means positive infinity, again with parentheses for the y values. Next, for whether this is a function or not, so it definitely doesn't look like I can draw a vertical line that touches twice anywhere. We come kind of close here towards the center of this thing, but there's no double touching for vertical lines, so this is a function. And then for increasing intervals, so it looks like this thing is actually, as we go from left to right, this thing is going up the whole time. So we're increasing from negative to positive infinity as well. We're not decreasing or constant anywhere, so this one is done. On this graph, the domain, the x values, going from left to right, we've got -5 on the far left and 0 is as far right as we can go, and those are both solid dots, no breaks in between. So this is going to be bracket -5 comma 0 bracket for domain. For range, I'm talking y values from bottom to top, so we can go as low as -3 with a solid dot, and as high as +3 with another solid dot. So that's going to be a -3 bracket, +3 bracket. For whether or not this is a function, is it possible to touch this graph twice with a vertical line? It is, right here for example. So this is telling me that I have one x value giving me two different y values, which means we're failing the vertical line test. This thing is not a function. And since it's not a function, I don't worry about increasing, decreasing, or constant intervals. For this problem, let me figure out the domain and then some other information about this graph. So for domain, that's the x values going from left to right. It looks like with these arrows here, we're going left forever and right forever, and there's no breaks in between. So this is going to be one whole interval from -infinity to positive infinity. And we'll use parentheses because we always do that on infinity, because you can't actually equal infinity. Now for the range, the y values, how low can we go? We're going down forever, so -infinity is our left part of our interval here. And as high as we can go is going to be 3. We can get to exactly 3 here, so we're going to have a bracket on 3. So -infinity comma 3 bracket is going to be our range. For whether or not this is a function, it definitely is, because no vertical line we draw across the interval here is going to touch more than once. So this is a function, passes the vertical line test. For increasing intervals, it looks like we're increasing from negative infinity until this turnaround spot here at x equals 0. So negative infinity comma 0 is our increasing interval. And then from 0 to positive infinity is going to be where this graph is going down, where it is decreasing. For this graph, the domain, the x values that this covers, for the left side, we're going left forever with this arrow. With the right side, we are going right forever. So we're going from negative infinity to positive infinity for x values, and we'll use parentheses on that for our domain. For the range, we're a little bit more limited. So we can't go any lower than -1, it looks like, and we're going to be at exactly -1 for the y values. For y values, as high as we can go, we can't go any higher than +1. So we're going to do bracket -1 comma +1 bracket. Now for the whether or not this is a function, every vertical line I draw is going to touch at most one time across the interval here. So that's going to be a yes for this being a function. In terms of where this is increasing, we only have one little increasing spot from about -2 to +2 where this thing turns around. So we'll write -2 comma +2 for where this graph is going up, where it's increasing. Decreasing, we've actually got two spots. We've got from negative infinity, we're decreasing at a very slow rate until we get to the x value -2. And then we're going to have to union that together with +2 to positive infinity.